I want to say a very big thank you for joining me on this presentation, a primer on blockchains and RSK. I also want to use the opportunity to say a big thank you to the organizers of this event for giving me the opportunity to share my knowledge with you people. They've been able to put together an amazing event. I mean, organizing an event that brings people together from every part of the country. I even heard some people came from outside the country. I mean, that's amazing. So a big congratulations to the entire organizers of this event and those volunteering to make this event a success. Yeah, so my name is Gino Osahon. I currently live in Abuja, Nigeria, okay? I work as a developer advocate at IOV Labs, okay? And I must say it has been an amazing experience of learning for me, working at IOV Labs. They have a good work culture and they are open to work with anyone that's talented from around the world. Okay, we have about employees of IOV Labs are working from 22 countries around the world. Okay, and I was very, very happy that they gave me the opportunity to also contribute from Nigeria. You can connect with me. I hope you can see this slide very well. Are you seeing my social media handles? Yeah, so you can connect with me on social media using these handles. You can see a QR code. You can scan that QR code and have access to the information I'll be talking about on the slide. So I have that QR code on a lot of the slides. So just scan them and you have the information. Before I go to the next slide, it would be good to have some of you here join us at IOV Labs. I have created a slide for that where I'm going to share how you can come join us at IOV. It's actually fun working with IOV Labs. So I have been able to put these key resource URLs for you. I encourage you to take time when you have a chance to look at them. We have the RSK developer portal, and you can access it using the URL developers.rsk.co. We have the RSK community Slack, where every person interested in the RSK blockchain can connect and network with other like minds. You can access that using developers.rsk.co/Slack. We have our research forum where a lot of discussions happen about the RSK blockchain. So if you want to contribute to the blockchain, if you have ideas on how to improve the blockchain and you want to discuss about the blockchain, you can go to research.rsk.dev. Then we have the RSK mainnet stats where statistics about the RSK blockchain can be found. We also have the white paper. The white paper gives a detailed description of the RSK blockchain. So the aim of my presentation is to introduce you to the RSK blockchain, okay? But the core concepts behind the RSK blockchain requires you to understand some terms, okay? And some of these terms are very technical. So what I'm going to do today is to define some of these terms for you so that you get familiar. A lot of you might know about them already, okay? But I need to define them so that we can build the foundation before I tell you about RSK. You are also encouraged to do your own research about these terms, okay? Do your Google research. I also have I have some URLs that I will share with you that you can use to also do research about these terms. So over here, we have a list of the terms that I'll be defining at a glance. So We have about 20 of them, you know, so, and it's a lot, so we need to get started. And at the bottom here, you see a marker. So what this marker will do is that as we move from one of the terms to other, the marker will tell us which term we are currently talking about as I continue the presentation. So this is the first term that I'm going to define today. How many of you have heard about this term before? Signify by raising your hands. Okay, so I guess we don't, okay, it's fine. I'm just going to introduce them or define them in my own terms. You are encouraged to do your own research. So you can define distributed ledger technology as a digital system where every member in a peer-to-peer network can contribute data to that network. Okay? If you look at the image I have over there, this image is depicting a peer-to-peer network. And I just gave a definition that every member in a peer-to-peer network can contribute data that is stored on that network. Okay? One other interesting thing I want you to know about distributed ledger technology is that data on the distributed ledger technology is not stored on a central data store, but instead it is stored locally on the computers of those participating in the network. So instead of having one central database where everybody push data to, data is distributed. You have it on different computers. So what that enables every member in the network to do is that they have a common view of the data. Okay? The same data you have is the same data every member in the pair has. The next term is blockchain. Okay, please, how many persons have heard about blockchain, the word blockchain? Okay, good. Because blockchain is actually changing the tech space around the world. Okay, okay, let me just go into definition. You can define a blockchain as a decentralized digital ledger or database of transactions. Okay, and these transactions are encrypted. They are immutable. You know about encryption, how WhatsApp blew up, end-to-end encryption. So data in the blockchain are encrypted. They are immutable, which means you can't change them. Once you put them, you can't change, you can't alter or remove them. And they are duplicated. What that means is that one piece of data is duplicated among the computers of everybody in the network and distributed. So you can say typically that a blockchain consists of a series of blocks that are chained together. Okay? If you look at the image over here, you will see that we have 3 blocks and they are all chained together. Now, if you take a closer look at each of the blocks, I don't know if you can see it from there, you will find out that we have transactions. So that's why we said blockchain is a chain of blocks, and each of these blocks, each of the block contains a collection of transactions. So blocks and the transactions in them need to pass validation before they are added to the blockchain. So we have people called the miners. Miners are the ones who validate all transactions, and they assemble them into a block and now put them on the blockchain. One interesting thing is that blockchains are the first and still most popular form of distributed ledger technology. Although we have other forms there, but blockchain is the first and most popular. The next term I'll define is block. Remember, we started building up distributed ledger technology to define blockchain, and now block. I already defined block in the previous slide where I told you that a block in a blockchain is a collection of transactions. I've said that before. So by way of analogy, you can think of a block as a page of a ledger, a single page of a ledger or of a record book. If you have a record book, one of the page, you can think of that page as a block. A block is a permanent store of records which, once written, cannot be altered or removed. Each block, I love this about the blockchains, each block is identified by a unique identifier called the hash. If you take a look at this image, we have 3 blocks, and all of them have unique identifiers called the hash. So what happens about the hash is that in the blockchain, all the blocks are linked together. And remember, they all have unique identifiers. So, for example, block 2 will contain the hash of block 1. They all have hashes. Block 3 will contain the hash of block 2. That's how you can trace them back. You can compare this to singly linked lists. Those people who do data structure, yes, and algorithm, data structure, you should know singly lists. The only difference is that hashes replace pointers, right? Pointers. In singly linked lists, you have pointers connecting nodes. So also in the blockchain, you have hashes. So the next term that I'll define is called transactions. Transaction. Transactions are data added to a block. I've said this because I said a block is a collection of transactions. And now I'm explaining transactions and saying transactions are added to a block. So you have a block, you get all the transactions and you add them into the block. Now, each transaction must be signed by an originating account and targeting a specific address. You want to send tokens or cryptocurrency to your brother, your family. You know, it has to start from you, and you specify the address of the person you are targeting. Transactions are the fundamental units of a blockchain platform. Almost everything else about the blockchain is designed to ensure that transactions can be created, validated, propagated on the network, and finally added to the common view of transactions, which is the ledger. So this is a typical transaction. Maybe you are sending 1 Ether to your cousin, okay? That transaction that is originating from you and going to the address of your cousin, it's like this. And you have different fields in a typical transaction. I'm going to get to that. Bitcoin. Bitcoin is amazing. It's an amazing technology. Bitcoin is the first implementation of the blockchain technology. The concepts of transactions, blocks, blockchain, which are industry standards today, were all invented and pioneered by Bitcoin. The Bitcoin network has a single purpose, which is its cryptocurrency. We know the Bitcoin cryptocurrency, like BTC, okay? You can buy BTC, you can sell it, you can exchange it in a peer-to-peer manner without an intermediary like a bank. I think that's the genius behind the blockchain. And don't forget that I told you that everything you are hearing today about the blockchain was invented by Bitcoin. It removes the middleman, the banks. If you are doing transactions, you want to send money to your cousin in the US, maybe use Western Union or use a bank. It takes time. And these banks, it makes the transactions expensive. So just imagine taking them out and dealing with your cousin. All you need is his address. So transfer occurs by means of cryptographic signatures on transactions, where the sender digitally signs and the rest of the network, including the receiver, verify the digital signature. The next term I'll try to define is blockchain consensus algorithm. A consensus algorithm is a procedure implemented in code designed to allow peers to agree upon a common set of data. It's a procedure that allows peers in a distributed network. As you can see the image over here, this is like, you can call this like a peer-to-peer network. You have different people. Now, how do they take the decision on which is the correct data? So they use consensus algorithm. We are going to check out some of the consensus algorithm. All the peers in a blockchain network run the same code. The code contains rules that allow all nodes to reach an agreement about some data. In the case of blockchain, consensus is needed. So one thing about the blockchain is that we have the people they call miners. I'm going to get to that slide, but miners are the ones who use consensus algorithm to decide which is the next valid block. You know, the blockchain is a chain of blocks. It keeps growing. They keep adding blocks. They keep adding blocks. So as the first miner to add a new block gets rewarded, but I'll get there. Proof of work consensus algorithm is the most common consensus algorithm out there. It's the most common. We have different consensus algorithms, but proof of work is the most common. Okay? So what happens, I think I just explained well. What happens is that miners, okay, this, like you can see the picture over there, we have miners. They compete with each other to decide who validates the next block on the blockchain. Okay? So what happens is that the whole process of mining, it's about finding a solution to a computer calculation. And you can do this using powerful computers. Okay? So you can have a problem, and for you to be the one to decide the next block, you have to use your computing resources to find that solution. And when you get the solution, you broadcast it to the network and say, hey, I found the answer. And every other miner stops, and you get your reward. While proof of work consensus algorithm is the most common, proof of stake is the second most common. Okay, and we have platforms. For proof of work, I know about Bitcoin using proof of work. I know about the RSK blockchain using proof of work. For proof of stake, you might have heard of Cardano. They do it. So for proof of work, instead of miners competing with each other to solve that problem, to find the answer to that problem, in proof of stake, okay, if you want to stake, a user will have to stake an amount of cryptocurrency together with a block. You know, you stake an amount and say, hey, I want to submit this block to the chain. If you are successful, you get reward, you get compensated in cryptocurrency. Now, here is something interesting. If you are unsuccessful, you lose your stake. And that's called slashing. Okay? So proof of work and proof of stake are the most common blockchain consensus algorithms. So different blockchains use different consensus algorithm. So these are other types of consensus algorithms that blockchains. Yeah, you have many types, and these are some of them. We have proof of elapsed time, proof of authority, proof of capacity, proof of activity, and proof of bond. Smart contract platforms. How many smart contract developers do we have here? Smart contract, please, let's connect a beg after this session. Smart contracts, it's the in thing now in tech, okay? Smart contracts are programs stored on the blockchain, of course developed by developers and stored on the blockchain, and they contain both codes and data storage. The program runs when predetermined conditions are met. They do so automatically and in a deterministic way. So you can use smart contracts to automate agreements between parties. You know, you have my picture there. Between parties, you can use smart contract to automate that process so that all participants can be immediately certain of the outcome. Now, you can do this using traditional way of agreements, of making an agreement, you know, but smart contract is the first to do this without an intermediary. For example, like, let me give an example. Or we have so much more to cover. But just know that they can be used to automate the execution of an agreement so that all participants can be immediately certain of the outcome. While that is possible using other means, smart contracts for the first time enables that to happen without the need to involve any intermediaries or other third party. So remember we've talked about transactions, how transactions are very important to the blockchain. Now let's look at different types of transactions. Not all transactions are the same, and you can achieve different things using different transaction types. These are some of the transactions, and we'll take a look at them. The first type of The first type is called cryptocurrency transfer transaction. Blockchain transactions are messages like email, which are digitally signed using cryptography and sent to the blockchain network for verification. Transaction refers to an action initiated by an externally owned account. In other words, an account owned by a human and not smart contract. The second type of transaction is Coinbase transaction. A Coinbase transaction is the first transaction in a block. Remember we talked about how block is a collection of, so the first one is Coinbase transaction. And this kind of transaction is only created by the miners. I talked about the miners, right? You know who the miners are. The miners use, sorry, and I have to control the two slides. So miners use Coinbase transaction to collect block reward for the work they've done and any other transaction fees collected by the miner. So Coinbase transaction is it's a kind of transactions that miners use. Smart contract interaction transaction. After you write a smart contract, after you create it, you will deploy it on the blockchain, okay? And when predetermined conditions are met, they come on automatically. So smart contract transactions, after deploying a smart contract, you need to interact with it. You need to call it to send tokens or do anything else. That is, you are interacting with the smart contract that has been deployed. Smart contracts are made up of functions. You write functions in them. And from From the outside, you can call a particular function, and it does something for you. Oh my God. So the next one is token transfer transactions. We all send tokens. They do one simple thing. They transfer token from one address to another. The token in question must be ERC20 tokens. I hope I'm not speaking one kind of language that nobody's understanding. Huh? Yeah, I'm going to share this slide so you have access to it. And like I said, do your own research. But the blockchain is open source. You can't talk about open source without talking about blockchain, okay? And it's a technology that, please, we should start looking into. As a developer, you should start looking into the blockchain, how you can be part of it, because we had Web 2.0, where you had the likes of Facebook and all these guys come out. But we are now in which of the web? Exactly. So if you don't want to advance or push yourself or develop yourself, man, you'll be left behind. Blockchain is the future. Web 3.0 is the future. So the tokens involved in token transfer transaction must be ERC20 standard. Tokens, if you have ever written a smart code, one of the simplest program you will write if you are learning the blockchain is a token. You can create your own token. It's very, very easy, simple, because we have standards that have been created and validated. All you just need to do is to implement those standards. So token transfer transaction, they do one specific thing, which is to transfer tokens. And that token must be an ERC20 token. So tokens are smart contracts. So token transfer transaction is a specific type of smart contract interaction transaction. I talk about smart contract, which is you write a smart contract, deploy it, and you call a function on the smart contract. We've been talking about transactions. Now, let's look at transaction fields. A typical transaction contains different fields. Some of the fields, you have the from field, which contains the sender's address. You have the to, which contains the smart contract you are calling, or your friend's address where you want to send your token to. We have nonce. Nonce is what miners compete to get. Once a miner gets the nonce, he broadcasts it to the network and every other person stops, and the miner gets rewards. We have what they call gas. We're going to get there, and data. So gas, I don't like to describe it using the traditional gas, but it's somehow kind of similar. Gas is the internal pricing for running a transaction. When you send tokens, interact with smart contracts, or do anything else on the blockchain, you must pay for that computation. And that payment is calculated in gas. So whatever you do on the blockchain, as you're sending cryptocurrencies and all that, interacting with smart contracts, you pay using gas. So we have gas units. A gas unit measures the work being done, but it doesn't have a monetary value. Gas units are ascribed to the smallest types of work done on the blockchain. Anything you like, you must pay for gas. You want to go from point A to point B, you need to buy gas, right? You want to go from here to Abuja, you need to buy an amount of gas. The benefit of gas units is that they are deterministic. The same transaction will always cost the same amount of gas units. Gas price. Gas price is the amount that the user is willing to spend on the particular unit of gas. If you are familiar with the blockchain, you want to send, but like, you people send cryptocurrencies, right? How many people do trade cryptocurrencies? Ooh, I hope my audience, like, If you have not been doing blockchain, please, after this event, find time to give it a try. It's very, very important. Gas price, it refers to the amount that must be paid to miners for processing transactions on the blockchain. Every transaction you do has to be validated by miners. Now, how do you pay them? You pay them using the gas price. That's how they get their money. Gas fees, payments made by users, price for computing energy. Now, you can use this formula to calculate the gas fee you will spend for a particular transaction. You can use gas unit multiplied by gas price will give you the gas fees. Gas limits refers to the maximum amount of gas that you are willing to spend on a particular transaction. Gas used. I mean, related to our traditional life. Like I said, you want to go from point A to point B, you need to buy an amount of gas. How much do you pay for that gas? What's the unit, what's the quantity of gas you are buying? So we have those real-world concepts being implemented on the blockchain. So we have what they call layer 1 blockchain and layer 2 blockchain. Layer 1 blockchain is the term that describes the underlying main blockchain. It is defined as a set of solutions implemented on the base protocol of a blockchain in order to improve its function and scalability. Layer 1 is the main blockchain. We have layer 2 that I'll also talk to you. This is important because when we are talking about RSK, the RSK blockchain, we'll come to this layer 1 and layer 2. Layer 1 blockchain is responsible for its own consensus, and it is only aware of its own network. So layer 2 blockchain is what gets built on top of the base chain, which is the layer 1 blockchain. And that's what is happening in the RSK ecosystem. RSK is a layer 2, but we'll get there. So layer 2 blockchain is what gets built on top of the base chain in order to improve its scalability. Now, layer 2 is aware of its own network and the network of the underlying layer 1. Remember, layer 1 is just only aware of its own network, but layer 2 has to be aware of the underlying blockchain and its own. So layer 2 can use the consensus mechanism. Remember we talked about consensus. Should I be asking questions as we go so that I know that you have, it's as if I'm telling stories like, please, I beg. I came all the way from Abuja just to share this thing with you. Okay, I beg. Okay, good. So we have what they call merged mining. I've told you about mining. Now, merged mining. Merged mining is the process that allows RSK blockchain to be mined simultaneously by the Bitcoin miners. Now, this is huge because we have Bitcoin miners. Now, the same Bitcoin miners are the same ones using the same resources, not like they do this one separately. They do it simultaneously. So they mine Bitcoin and still use that power to also mine the RSK blockchain. That's key. Now, this is possible because Bitcoin is layer 1 and RSK is layer 2. But the interesting thing is that they use the same consensus algorithm. Please, just mention 2 consensus algorithms that I've mentioned here, please, before. God bless you. Okay, they use the same proof of work consensus algorithm. That's why miners who mine for Bitcoin can also mine for the RSK. RSK is the most secure smart contract platform in the world. RSK adds value and functionality to the Bitcoin network by enabling smart contracts on top of Bitcoin. I told you that Bitcoin is just about one thing. What? Cryptocurrency. Bitcoin, it's all about cryptocurrency. So Ethereum now came out and gave the power to build smart contracts. Bitcoin is just a cryptocurrency. But what RSK is doing is that RSK enables you to build smart contracts on top of Bitcoin. Remember, Bitcoin is the first. It's the first implementation of the blockchain technology. So it has so much power. RSK is building on top of Bitcoin. Oh, I keep missing this. So let us look at a technical overview of the RSK. RSK is the most secure smart contract platform in the world. It adds value to the Bitcoin network by enabling smart contracts developed and secured by the Bitcoin. It helps grow the Bitcoin ecosystem. RSK is what is Bitcoin. I don't think it's going to evolve more than its cryptocurrency. But because of how powerful it is, RSK is enabling people to build smart contracts. The reference implementation of the RSK node is RSKJ. How many people are Java developers? Yeah, so RSKJ is built using Java. And guess what? RSKJ is open source. So it's open source. You can find it on GitHub using the URL github.com/rsk-smart/RSK. It is licensed under the LGPL v3. And we have a white paper that gives a detailed description of the RSK blockchain. So if you are not sure where to start, how do you contribute to RSK? If you're not sure where to start, the RSK improvement proposals are a great place to propose, discuss, and suggest changes to the RSK. Since it's open source, you can clone it, add your own feature, and we welcome contributions to the RSK platform through PRs. So after cloning, you can just send a pull request. But all these discussions happens on the RSK improvement, we call it RSK IP, which is RSK improvement proposals. This improvement proposal is also open source, okay? And you can find it on GitHub using github.com/rsk-smart. Look, I have all these URLs. I'm going to share it. I hope if I can have your emails, I'll be able to share this round. So how is RSK different? We have blockchains out there. How is RSK different? What sets it apart? The answer, in short, is how RSK is interconnected with Bitcoin, both in the network level and in the cryptocurrency level. So let's look at RSK connection to Bitcoin on the network level. I've explained this before. How they are connected on the network level is that Bitcoin is layer 1 blockchain and RSK is layer 2 blockchain. So it does something called merge mining, which I've explained, where Bitcoin miners include summaries of the change in state of the RSK blockchain within Bitcoin blocks. RSK is the most successful merge mine project with Bitcoin, having attracted more than half of all Bitcoin mining hash power. So half of the people who mine for Bitcoin mine for RSK. So let's look at how RSK is connected to Bitcoin on the currency level. RSK has its own cryptocurrency called Smart Bitcoin and uses the symbol RBTC. BTC and RBTC are convertible in both directions, meaning you can convert RBTC to BTC. You can, they are bi-directional. And you can exchange them in a one-to-one exchange. Like, how much is one Bitcoin right now? $42,000. So what that means is that the RSK cryptocurrency, which is RBTC, is also 40 whatever thousand naira. So it is one-to-one. I mean, which other cryptocurrency is even as high as that? So, but RSK is, you can exchange it in a one-to-one rate. So we have a tech, or we have something that controls this, and it's called POPEG. POPEG. POPEG means proof of work peg. Proof of work peg with Bitcoin. You can take a look at this, you can take a look at the POPEG architecture to understand how POPEG works. What sets RSK apart is not only its connection to Bitcoin, but also its connection to Ethereum. The RSK virtual machine used to execute smart contracts on RSK uses the same OP codes as the Ethereum virtual machine that executes OP code on Ethereum. This enables smart contracts to be ported from Ethereum over to RSK with minimal effort. So if you are a Solidity developer, if you are an Ethereum developer here, what this is saying is that the virtual machine that runs smart contract on the RSK platform is in sync with the one that runs on the Ethereum platform. So if you've written a code in Solidity, you can deploy that code, that same code, on the RSK platform. I mean, this is helping a lot of Ethereum developers to have options. I'll tell you why. RSK is cheaper, okay? So the RSK node exposes the same JSON RPC interface that Ethereum nodes, such as GET, do. This enables existing software that Web3 users interact with, such as crypto wallets and decentralized apps, to interact with the RSK network. So for you to just take your project you've written on the Ethereum, the only thing you need to change is the configurations. Every other thing will just work. So IOV Labs is the company that is behind the RSK network. Now, it didn't just stop at building just a blockchain, okay? It also is behind what we call Reef. So IOV Labs is the company behind RSK, the blockchain, and Reef. RSK infrastructure, that's Reef that we just looked at. This infrastructure is a collection of applications and services that are designed to complement blockchain-based decentralized apps. The RSK infrastructure also makes use of ERC20 token. So some of the Reef's apps and services are on-chain, and payment for these services is denominated in the Reef token. So we have our own token too that you can use when you want to. So the thing is that as a dApp developer, as a decentralized application app developer, okay, you can, Reef are services and platforms that we have built on the RSK blockchain. And you can plug them into your application, to increase scalability and to include a lot of other functionalities that would take you years to build. So using the RSK blockchain, I've just said it. Using the RSK blockchain as the backbone, one can build decentralized apps and complement it with selection of these apps and services. So let's conclude with some, let's wrap up about RSK with some important information. I'll just try to read this. Half of the Bitcoin network merge mines with RSK, and this is the basic of the claim that it is the most secure smart contract in the world, because half of the Bitcoin miners merge for the RSK blockchain. It takes around 30 seconds for each block to be mined. This is much faster than Bitcoin. However, it is slower compared to Ethereum in theory, but faster in practice due to congestion on the Ethereum network. You can do some maths around the number of transactions that can fit onto each block and the block interval to work out the RSK support. RSK supports 10 transactions per second. This is higher than both Bitcoin and Ethereum. In terms of gas fees that users pay to add transactions onto the network, RSK is extremely cheap. Typically, Ethereum is 40 times to 50 times as expensive in USD terms. And during period of high congestion on Ethereum, we've seen it gone up to 100 times. So RSK is cheaper. So here are more resources that you can take a look at. General information, rsk.co, our developer portal. RSK, part of my job is to maintain the developer portal. So RSK mainnet starts, the RSK white paper that gives you a detailed description of the RSK blockchain, and the RIF white paper. More resources. So thank you very much. Over here, if you scan this QR code, you have the address to our Slack channel. And if you scan that QR code, you have the address to our developer portal. Just 1 minute, please. Let me show you the career. Oh. Yeah. So if you are interested in the blockchain, if you've liked some of the things I've said, I know not everything, but some, and you would like to join IOV, IOV is hiring for multiple roles right now, so check out our career page. Scan that QR code, and you can land on our career page. When I joined IOV Labs, I was the 3rd Nigerian to join IOV Labs. But right now, we have 8 Nigerians that are working at IOV Labs. You will join a diverse and fully remote team from New Zealand to Singapore, to Nigeria, to UK, to the US, to Argentina, and many more. Thank you very much. Do I still have time? Maybe I can take questions. And I didn't even time that. How much time did I spend? Oh, okay. So I'll be ready to take your questions. Okay. What is? Oh, okay. IOV Labs Twitter handle. So the thing is that IOV Labs as a company, it's not on Twitter. So what is on Twitter is RSK, the RSK blockchain. Please just tag RSK Smart, RSK Smart. Yeah, RSK Smart. But IOV Labs, we have a LinkedIn page, okay? And if you are interested to, just tag RSK Smart, please. RSK Smart on Twitter. So during the remaining time of the event, this amazing event, I'll be around. I'll be open for networking. I've sent some of you, I try to connect with you on LinkedIn or, yeah, okay, yes, okay. Okay, all questions are welcome. No question is.
Okay, I'm trying to move away just so that the speaker doesn't start to cry. I have another question, and it's a petty question. And it's It's with crypto terminology, so that's why it's petty. And I want you to tell me why, because it doesn't make sense to me why they actually call transaction fees gas fees, because it's not literal gas.
It's not.
It's not gas. Like, it's just a transaction that somebody somewhere is paying for. So why is it called gas fees?
I don't know if I have a good answer to that, but I could take that down.
That's why I said it's a petty question, because it still doesn't make sense to me up till now. Like,
No,
why
so
is it called gas fees?
the thing is that we have people called miners who are actually validating your transactions. When you create a transaction, for it to be stored on the blockchain, the miners, they do computation. They use high, powerful computers to validate. They have to validate that your transaction. So you pay them.
Oh, yes, I know. I know that they are getting paid. Like, yes. And I know that they're
So, but
getting
it is
paid.
that why did you
but
call it gas?
why is it not called transaction fee?
Fees.
Why is it gas fee? Where is the gas? It's not diesel. It's not literal gas. That's just the question. Don't mind me. I'm just here goofing around.
Yeah. So can anybody?
But I thought you had an answer to that question,
I don't
because
have
it is an honest concern for me.
Okay. Okay. Noted.
But an irrelevant concern. It's just a concern. Amebo.
You want to help out? You want to help out?
Yeah.
Or you have a question? Okay, please. Adora, somebody said he has answer. You have an. Oh. Yeah, Polygon. Yeah. Thank you. Thank you.
Okay, so I think testing. Okay, so the question was, why is it called gas fees, right?
Yeah.
So the thing is, technically it's transaction fees, right? You need those money to process certain transactions, right? Web3 folks. Are there Web3 folks here? Okay, awesome. Now, think of that you want to move a car from VI to here. You need gas.
Yeah.
So the reason it's called gas fees is Web3 is powered by something called hype, right? The community, the hype. For example, Bored Ape appreciated also that because the hype was good, the utilities were great and stuff like that. So the idea of that gas is that like you need that gas in your car to move from point A to point B. But technically it's transaction fee, but it's just nice when you say like gas fees.
Gas fees.
Or you're a developer and you say, what do you do? I'm a Web3 developer. I'm a Web3 designer. Come on, man. It's still the same thing. It's not like you use another tool as a designer. You still use Figma, Sketch, and stuff. But like, it's just cool to say Web3 designer, that kind of stuff. So it's just a hype, but then like gas fees, yeah?
Yeah,
So.
yeah. I think, thank you very much. Yes. You know, that analogy of going from point A to point B. So what's the amount of gas you will need to go from point? So in transactions, it's also like that. How much are you going to pay to send so amount of cryptocurrency to this person? Okay, somebody had another opinion, right? I think I still have like 5 minutes or so. If my time is up, just then you have a question.
Okay, so like when you talk of gas, on the Ethereum smart chain you have gas, then you have GUI. That's like the smallest amount of Ethereum you can get. So when someone says, okay, you want to do this transaction, say you want to transfer something on the Ethereum smart chain, it costs 21,000 gas. That's not Ethereum, it's just gas. That's what they are saying is going to cost you. Then when you then say that, okay, then we are now going to add this amount of GUI to it. So say 200 GUI to actually like move this amount of gas, because gas comes from, if you actually like break Ethereum code down, like you bring it down to its own bytecode, they call them opcodes.
OP codes. Yeah.
Those OP codes actually have like their values, their different gas values.
Yes.
So when you compile your code, the code is already expensive. It has gas. If you want to run this particular code, you pay this, you bring this amount of gas. Then for it to actually like put it on Ethereum smart chain, you pay this amount of GUI. So gas is not necessarily transaction fee. It's just that the code itself has its own cost. It's just like when your computer is running memory and you have you open Google Chrome and you open Figma, it costs you like maybe 1 gig RAM.
Yeah.
That's just what gas is like. Then when you then pay like your GUI, maybe your 200 GUI, your 1,000 GUI, that's when you then actually like get the fee. They're not like, okay, I'm moving this amount of thing. So this gas multiplied by this GUI is now going to give you that transaction fee on the Ethereum smart chain. So it's just like gas is actually like okay, this is the amount of memory you want to use within the blockchain.
I remember.
So you have to pay this amount of GUI to actually like move it.
I remember in Solidity, if you write shitty codes, okay, you pay like if you write good codes, people will pay small amount of gas to run to call your functions. But if you write shitty code, they'll pay huge amount of money. Because I think all those variables, all those functions and all those things you declare in your programs are attached to an amount of gas. So if you want to write a program that will be cheap for your users, you structure your programs very well. We still have
one question. Hi, Gino. So my question is this. It's the first time I'm hearing of RSK, and other layer 2 sort of technologies I know of is, an example is Polygon, right? And one direction that increases adoption in the blockchain space is gas fees. That's one thing.
Yeah.
Does RSK offer the same cheap transaction fees just as you have in the Polygon ecosystem?
Yeah, so I don't know how much it costs to do transactions on Polygon, but what I know is that for Bitcoin and Ethereum, when you compare Bitcoin, Ethereum, and RSK is way cheaper than Bitcoin and Ethereum, but I don't have that data yet if it's cheaper than, but if you tell me, I know we have the...
Shodipo.
Shodipo is here. If you can tell us how much transactions cost on Polygon. Transactions are very, very cheap on RSK. Okay. Yes, I think can I just take one more question and that will be it. I'll be outside and the whole of the event I'll be ready for networking. Okay, sir. Stacks. I think I've heard about it, but...
They're trying to implement smart contract functions on the Bitcoin blockchain. So, how does RSK compare to Stacks?
Yeah, so maybe they also merge mine. Maybe they merge mine. So they are using Bitcoin as layer 1 and the stack as layer 2. Okay, so it's maybe the same thing that RSK is doing. But so far, we know that RSK is the most successful merge mined platform with Bitcoin.
Is it like start you can look at, or is it just word of mouth? Is it like a start we get?
It's start.
Or is it just word of mouth?
No, like I have a slide that.
Like in comparison to like start.
Okay, no. Maybe I'll just do that research and let you know.
Also, I wanted to ask you a question about your TPM. And yeah, you said Ethereum is 7 right now. So like Ethereum is planning to move to the proof of stake proof of consensus mechanism. And so would RSK still be faster? Did you get any of that?
No, I didn't get it.
So yeah, I was talking about the TPM of Ethereum.
Yeah.
Comparison to RSK. And soon, Ethereum is moving to the proof of stake.
Yeah, okay, consensus, mechanism.
Would RSK still have proven advantage over Ethereum then?
So the thing is that there is an argument about how effective is proof of work and proof of stake. They are both different arguments. The only limitations about proof of work is its non-eco-friendly nature, because you burn power. You burn a lot of power when using proof of stake. But, I mean, people burn flare gas every day. I mean, you are using this gas to secure a blockchain, like to make transactions cheaper. But me, I don't see that as much of a problem. But proof of stake has its own. Thank you very much, my people. Thank you.
Yeah, you're welcome. Please. Keep it going. Keep it going. Yeah. Thank you, Gino.
Well done.